Some of you said you'd like to see a redox reaction that was a net reaction balanced, and so I have one here that's tied together with the stoichiometry problem. So the problem says in acidic solution, copper metal is reacted with a nitrate ion to yield a copper 2 ion and nitrogen monoxide. So let's just write that down. We got a copper metal plus a nitrate ion, NO3 minus, yields a copper 2 ion, copper with +2 charge, plus nitrogen monoxide. Now, obviously, this is not a complete reaction because you don't find ions by themselves. There are some spectator ions that are not shown in this equation, and our job is to balance this equation. We don't really care about the spectator ions because they're not involved in this reaction. They're spectator ions, so you can't see them. We don't care what they are. The important fact is this is a net reaction, and we need to balance it. So we write our half reactions like this. We know copper is going to turn into copper with a +2 charge, and the other one would be involving the nitrogen. So we have nitrate turning into nitrogen monoxide. All right, when you're doing these redox reactions, you first balance the half reactions with elements. So you have one copper, you have one copper, so they're even already. Down here you have 3 oxygens, but only 1 oxygen over on this side. So we're going to need to balance it by adding some more oxygens. So where do we get oxygen? Well, the thing is in a solution. So if it's in a solution, that means that water is available. And it's acidic. If it's acidic, that means that hydrogen ions are available. So we can use water and hydrogen ions however we want to balance these equations. So you got 3 oxygens, you got 1 oxygen, so you need 2 water molecules. Because that makes 2 oxygens here plus 1 makes 3, and that balances over here. Up at the top, we didn't have to do anything. Oh, I forgot about the hydrogens. But down here, since we put those 2 water molecules in, that means we need 4 H's on this side. And once again, they're available because it's in an acidic solution. Now we're ready to balance our charge. So up here, the charge is +2. On this side, it's 0. We need to make the charges equal. They don't have to be any certain number, but they need to be equal. So I have to add 2 electrons there. And once again, you might be thinking, well, I've got to make both sides equal to 0. That's not the case. You just need to make both sides equal in terms of charge. All right, so there's our half reaction for copper. Is that an oxidation or is that a reduction? Well, it's an oxidation because the copper went from 0 charge on this side to +2, losing 2 electrons. In order to have your charge go up, you've got to take away negatives. Taking away negatives would, like, say, copper minus 2 electrons, but algebraically, if you had minus 2 electrons here and you wanted to put them on this side, it'd be +2 electrons over here, and that's how chemists write it. So when chemists write an oxidation reduction or oxidation reaction, they write the electrons on the right side to show that they're lost. Now down here, we've got 4 H pluses and 1 -1 for the nitrate, so our net total charge is 3. On this side, the charge is 0, so we need to make them even. So I have to add 3 electrons on this side because that would even out the charge. Now, just in case you're wondering, in terms of what the actual charges were, or the electron changes were, the nitrogen was +5 here, it's +2 there. In order to go from 5 to 2, you have to add 3 electrons, and there they are. All right. All right, now, we need to make the electrons even. So at the top, we have to multiply by 3, and at the bottom, we have to multiply by 2. So that gives us 6 electrons and 8 H pluses and 2 NO3s. And 2 NOs, and 4 H2Os. Up here, you're going to have 3 of these, and 6 of those. Now you're ready to add them together and cancel out things that show up on both sides of this arrow, on both sides of the arrows. So you've got 6 electrons. They cancel out these 6 electrons. I don't think anything else cancels. Scratch that. Let's erase some of this stuff down here so it doesn't confuse us. There we go. All right, now we're ready to add them together. So we've got 8 H pluses plus 3 Cus plus 2 NO3 minus yields a copper with a +2 charge plus, no wait, not a copper, 3 coppers with a +2 charge plus 2 NOs plus 4 waters. So I'm just adding up the things that are on both sides of the arrows. And that's our final equation. So that's how you do redox. You write the half reactions, you balance the elements, you balance the charge, then you make the electrons even, and you're done. Write the half reactions, balance the elements, balance the H's and the O's, balance the charge, and add them together. Oh, make the electrons even, and then add them together. All right, so now we need to do the stoichiometry. So we've got 20 grams of NO. In stoichiometry, the first thing you do always is change to moles. So you're going to have grams here, you're going to have moles here, and 1 mole would be 30 grams. And we know that because oxygen is 16, nitrogen is 14, 16 and 14 is 30. We need to label what we're talking about. The question asks what mass of copper was initially reacted. So we're going to use the mole ratio, put moles of copper, that's moles there, of copper. No, moles of NO there, it has to be moles of NO because we need to cancel that out, and moles of copper on the top. We put 3 coppers, because there's a 3 right there, and 2 NOs, because there's a 2 right there. Then we need to change moles to grams, so we're going to put moles of copper on the bottom, put grams of copper on the top, and 1 mole is 63.5 grams for copper. And you just multiply those things together. So it looks to me like the answer is just going to be 63.5 grams. Because, no, it's going to be 635 grams. So you're going to take 20 and times 3 times 63.5 equals, then you're going to divide that by 30 and divide again by 20, and you end up with 63.5. Yeah, that's right. All right, so 2/3 times 3/2, and then multiply by 63.5. And that's the end of it. And that's how you do stoichiometry. Would you like me to write, maybe I should write those steps down for you for balancing. So here's the steps again, one more time. So number 1, first thing you're going to do, step 1 in balancing redox, now we're back to balancing this equation, is write the half reactions and balance the elements. Number 2, when you balance, go back to number 1 for a minute, we balance the elements, use the H plus and water. All right. And then after you got the elements balanced, then you balance charge for each reaction, for each half reaction. Then the third thing you're going to do is, after you balance the charge, you're going to need to balance electrons. And then the fourth thing you do is add the equations. Canceling what shows up on both sides. And there you have it. Okay, hope that helped. Work on those on the practice sheets that I told you to work on, the 100 grams and the 46 minutes of stoichiometry fun and excess fun sheets. Good luck. I'll see you on Monday.